Yeah, okay, so now let me introduce scalars and vectors. So this was just the introduction part. Yeah, so for scalars and vectors, just those definitions which you know, like a scalar, this is just a quantity with magnitude only, without direction. We have things like mass, speed, and temperature. Now, when we go to a vector, a vector is a quantity with both magnitude and what? And direction. Yeah, so a scalar, when we say magnitude, we can also say size. Yeah, so yeah, these are just a definition. Now, let's go to what we call uh, representation, representing vectors, representing represent vectors. How do we represent vectors? So this is the part that where you should where the focus should start now. But this part is important, the introduction, knowing the definitions, because as I said earlier, my philosophy is in if you want to study anything, know the basics first. That's when things are going to be easy. So vectors, uh, the first one we say by represented by what? By arrows. So length is equal to what? Magnitude. Arrow is equal to direction. So what are we saying when we say we mean when we say length is equal to magnitude and arrow is equal to direction? What we mean is when you move from this point to that point, that's the length. You are measuring the length that you have moved from one point to another. Now, now the arrow will show which direction are you moving. So that's how we are representing the what? The vectors. For example, uh, we usually it is usually denoted by what? Denoted by bold letters. Bold letters or with an arrow. So the example, so it's not going to be clear, but the computer usually shows clearly. So it will be something like a bold letter, different from this one. This one, which is not a bold letter, it's going to have a what? A arrow on top. This shows that these two are vectors. So there's a difference between something which is just a normal letter and a vector. So there's this thing again you learned maybe in grade 12 we call Sokatoa. So it's really important in physics or in trigonometry and vectors. So these symbols, like not symbols but sin theta is equal to opposite over hypotenuse and cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. These things, they are very important. They are very important when you are going through this journey of vectors and trigonometry. So we go to this other thing, which is vector components. Vector components. So a vector, A, which is as an arrow, at an angle theta, can be split into two. So you should really pay attention when it comes to the components, vector component. That's where most of the questions comes. So the moment you just get the concept, then everything is okay. So let me draw this clearly. What we mean at an angle. For example, we have this, then a vector goes like that, then this angle is 30 degrees. Yeah, so we have y and x. So if this can be, this is f1. So when we say like vectors are split into two, what we mean is this one is going to be split like f1x is equal to f1x. If you want to find this, the magnitude of this, you say f1 cos 30 degrees. So for the x-axis you say cos, then for y-axis you say f1 sin 30. So this concept is very, very important. Yeah. So if the force is lying along the x-axis, so what you do is, for you to find this component,